Think about the last time you said the day felt long. Now imagine the sun rising, crawling across the sky, and not setting for nearly 2 months. Not 2 months of daylight with a break in the middle, 2 straight months of sun, then 2 months of pitch darkness, then it happens again, over and over forever. This is what a day actually looks like on Venus. And here is the part that breaks your brain. One complete day on Venus, from one sunrise to the next, takes longer than an entire year on Venus. A day longer than a year. That sounds wrong. It sounds like a joke. It is not a joke. Let's start with the basics. 1 year is how long a planet takes to orbit the sun, to complete one full lap around it. Earth takes 365¼ days. That is what a year is. 1 day is how long a planet takes to rotate once on its own axis, to spin all the way around one time. Earth takes 24 hours. That is what a day is. On Venus, one orbit takes 225 Earth days. So a Venusian year is 225 of our days. But one rotation of Venus takes 243 Earth days. Do the math. A single rotation, one single spin of the planet, takes 18 more Earth days than a full trip around the sun. A day is longer than a year. And it gets stranger. Venus does not just spin slowly, it spins backward. Every planet in our solar system rotates counterclockwise, the same direction they orbit the sun. Mercury does, Earth does, Mars does, Jupiter, Saturn, all of them, except Venus. Venus rotates clockwise. It goes the opposite way. Which means if you were standing on the surface of Venus, the sun would rise in the west and set in the east. Everything you know about the sky would be reversed. Why? How does an entire planet end up spinning the wrong way? Scientists have been arguing about this for decades, and there is still no single agreed-upon answer. But the most widely supported explanation comes from planetary scientist Alex Alemi and his colleague David Stevenson at the California Institute of Technology. In 2006, they ran computer simulations showing that a series of massive impacts early in Venus's history, collisions with other protoplanets during the chaos of the solar system's formation, could have gradually slowed the planet's spin, stopped it, and then reversed it. Not one single catastrophic crash, but a chain of violent encounters over millions of years, each one nudging Venus a little more off course until it was spinning entirely the wrong direction. Other researchers have pointed to a different force. Venus has an incredibly thick atmosphere, 90 times denser than Earth's at the surface. Some scientists believe that tidal interactions between this massive atmosphere and the sun's gravity could have slowly dragged Venus's rotation to a near standstill, and then, over billions of years, gently flipped it. We do not know which explanation is correct. Maybe both played a role. What we know is that Venus is the only planet in our solar system that rotates in retrograde, and whatever caused it happened billions of years ago. But the rotation is only part of the story. What that slow rotation does to the surface of Venus is far more dramatic. Because Venus spins so slowly, the sun does not behave the way you expect. On Earth, the sun crosses the sky in about 12 hours, then you get night. On Venus, a single stretch of continuous sunlight lasts about 58 Earth days. Then the sun sets, and you get 58 Earth days of continuous darkness. 58 days of scorching, unbroken sunlight, 58 days of pitch-black night. Then it starts again. Now here is what makes Venus truly terrifying. That 58-day stretch of sunlight does not mean Venus is a warm, pleasant place. Venus is the hottest planet in the entire solar system. Not Mercury, Venus. Mercury is closer to the sun, sure. But Mercury has virtually no atmosphere. Heat just radiates back into space. Venus has the opposite problem. Its atmosphere is roughly 96% carbon dioxide, the most potent greenhouse gas we know. Thick clouds of sulfuric acid blanket the entire planet, trapping heat in a runaway greenhouse effect that has raised the surface temperature to 465 degrees Celsius. That is 869 degrees Fahrenheit. Hot enough to melt lead, hot enough to melt zinc, hot enough to destroy every spacecraft that has ever tried to land there within minutes. And we have tried. The Soviet Union's Venera program was the most ambitious attempt in history to explore Venus's surface. Between 1970 and 1984, the Soviets launched a series of landers designed to survive that hellscape long enough to send back data. Venera 7, in 1970, became the first spacecraft to land on another planet and transmit data back to Earth. It survived on the surface for about 23 minutes before the heat and pressure destroyed it. Venera 13, launched in 1981, did even better. It lasted 127 minutes. In that time, it transmitted the first color photographs ever taken from the surface of another planet. The images show a flat orange-brown landscape of crushed rock under a sky that looks like a dim, dirty furnace. There is no blue, no green, no water, just rock and heat and crushing atmospheric pressure. The surface pressure on Venus is about 90 times that of Earth. Imagine the weight of the entire ocean pressing down on you, except it is not water. It is thick, toxic gas. In 1990, NASA sent the Magellan spacecraft to Venus. It did not land. Instead, it used radar to peer through the thick clouds and map the entire surface from orbit. Over 4 years, Magellan revealed a world of vast volcanic plains, enormous shield volcanoes, continent-sized highland regions, and strange geological features called coronae, massive circular structures formed by plumes of heat rising from deep inside the planet. The data from Magellan showed that Venus might still be volcanically active. More recent observations from the European Space Agency's Venus Express mission, which orbited Venus from 2006 to 2014, detected infrared hotspots consistent with active lava flows. Venus is not a dead world. It is a restless one. But here is the detail that haunts planetary scientists the most. Venus is almost exactly the same size as Earth. It is 95% of Earth's diameter. It is 81% of Earth's mass. It has a similar composition, a similar density, and it sits relatively close to Earth in its orbit around the Sun. Venus and Earth started out as twins, and something went catastrophically wrong. The leading theory is that Venus once had liquid water on its surface, maybe even oceans. Billions of years ago, when the Sun was younger and cooler, Venus might have been habitable. But as the Sun slowly brightened over time, more and more water evaporated into the atmosphere. Water vapor is a greenhouse gas. More water vapor meant more heat. More heat meant more evaporation. A runaway feedback loop that could not be stopped. Eventually, the oceans boiled away completely. Ultraviolet radiation from the Sun split the water molecules apart. The hydrogen escaped into space. Without hydrogen, there was no water left. Without water, there was nothing to absorb carbon dioxide and lock it away in rocks. The carbon dioxide built up and up until it choked the planet in a blanket of heat from which there was no return. Venus went from a world that might have supported life to the hottest, most hostile planet in the solar system, all because of changes to its atmosphere. And that is the part that should make you uncomfortable. Because Earth is right next door. Earth is made of almost the same stuff. Earth is already adding carbon dioxide to its own atmosphere, not from natural geological cycles, but from human activity. The runaway greenhouse effect that destroyed Venus is not science fiction. It is a documented planetary process that actually happened to a planet that started out almost identical to ours. Venus is not just a curiosity. Venus is a warning. Every time you hear a scientist warn about climate feedback loops, about tipping points, about the danger of a warming atmosphere that triggers its own further warming, they are talking about the same physics that turned Venus from a twin of Earth into a furnace. So the next time someone tells you a day is just a day, remember Venus. Remember that a day can be longer than a year. Remember that an entire planet can spin the wrong way and trap itself in an eternal slow boil. And remember that the only thing separating Earth from the same fate is the thin, fragile balance of the atmosphere we are actively changing. The day you take for granted is a gift. Venus would love to have it back.